Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on maximum speed of reciprocating pump during suction stroke and delivery strokes. So the theory regarding this maximum speed of reciprocating pump during suction stroke and delivery stroke, we have already discussed in our last lecture, and there we found one equation how to calculate the maximum speed of reciprocating pump. So here I have taken a question to find out this maximum speed of a reciprocating pump. So the question is given, find the maximum speed of single acting reciprocating pump. So in the first line itself, it is given what need to calculate to avoid the separation, which occurs at 3 meter of water absolute. The pump has a cylinder diameter of 10 centimeter and a stroke length of 20 centimeter. The pump draws water from the sump and delivers to a tank. The water level in the sump is 3.5 meter below the pump axis and in the crank. The water level is 13 meter above the pump axis. The diameter and length of the suction pipe are 4 centimeter and 5 meter while of delivery pipe. The diameter and length are 3 centimeter and 20 meter respectively. Consider the atmospheric pressure head is 10.3 meter of water. So this is the question given, and we need to find out the maximum speed of a single acting reciprocating pump. So first of all, I'll write the data given. Then only two equations are there. Like a single equation, if you remember, it can be applied for the both like suction stroke and for the delivery strokes. So first of all, we'll find out the data given. In the data given, if you see, it is given H separation. So to avoid the separation, which occurs 3 meter above of water. So that one you can write H separation. Okay, and this is given 3 meter of water, and that is absolute is given. And next is given pump cylinder diameter is given. So D equal to, we can write this is 10 centimeter, and this one we can write 0.1 meter. Similarly, the stroke length is given L. So L is given 20 centimeter. So this also we can write into meter, 0.2 meter. Next is from the stroke length we can calculate the crank radius R. So R equal to L by 2. So this one we can write 0.1 meter. Now next is the water level in the sump is 3.5 meter below the pump axis. That means this is the suction head. So from the center point, center line of the pump to the sump level of the surface. So that is nothing but HS. So HS is given 3.5 meter. Now next, if you see, and another one is given 13 meter above the pump axis. That means the water need to be delivered up to that level, that height. So that is HD. So HD is given 13 meter. Next, the diameter and length of the suction pipe are 4 centimeter and 5 meter. So suction pipe diameter DS, this is given 4 centimeter. So similarly, this also you can write, this is 0.04 meter, and length is given. So LS is given 5 meter, and the diameter and length. Okay, this is suction pipe. Okay, delivery pipe, the diameter and length are given. So this is the diameter and length for delivery pipe, 3 centimeter and 20 meter. So similarly, DD equal to 3 centimeter. So this also you can write 0.03 meter. And length of this is LD. LD equal to given 20 meter. Is more length than the suction pipe. And atmospheric pressure head is given. So atmospheric pressure we know that is H ATM. So this is our 10.3 meter. So these are the data given. So now we'll go for the calculation. So in the calculation, what we need to calculate, actually we need to identify what is the maximum speed of single acting reciprocating pump. So for the first we'll find out the maximum speed for the reciprocating pump during suction stroke. So in the condition of A, if you condition first A condition suction stroke, so let me write this is suppose suction stroke, and similar manner we need to solve for the delivery strokes also. So what is the formula for this? We have seen, so in our last lecture we have derived an equation. There we have seen the equation is given H ATM minus HS minus H separation equal to The formula is LS by G into capital A by small s into omega square R. Okay, so this is the formula we got in our last lecture derivations while discussing about the maximum speed of reciprocating pump during the suction stroke. If it is a delivery stroke, just LD, AS, HS will be changed. The remaining value will be as usual. So while solving this, let write down these values. What are the values we have? So 10 H ATM is nothing but 10.3, and this is minus HS equal to how much? HS is given 3.5, and H separation is given 3, and length of suction pipe is 5 meter divided by 9.81 into area of this. Okay, area of this is pi by 4 d square, and this will be pi by 4 d square again. So here only capital D square is nothing but 0.1. I can write here 0.1 square, and AS is given how much? Area of the suction pipe. Okay, diameter is given, so here we can write this is 0.3. I hope, yeah. Area of the, oh sorry, 0.04. So here I'll write this is 0.04 square, because pi by 4 both are cancelled. Now here into omega square into R equal to how much? R also we have calculated here 0.1. So now if you see this equation, what is the unknown is there? Omega. If you will be able to find out the omega value, then we can calculate the speed. So speed equal to, we can write there 2 pi n by 60. So n value we can calculate from here. So first of all, we'll find out here. You see this value 10.3, and this is 6.5, because the minus 6.5. So 10.3 minus 6.5. So that will be 3.8. So 3.8 here we can write the value. Let's see. 5 divided by 9.81, so this will be into 0.1. okay, 0.1 into again 0.1 into 0.1 divided by 0.04 again divided by 0.04, so 0.318. so here we got the value 0.3185. This much omega square, correct? So this is 0.318 omega square. Now what I'll do, I'll write omega square one side, and this is 3.8 divided by 0.318. Now here same thing I can write here, omega equal to, this is root over of 3.8 divided by 0.318. okay, now so here we can calculate the value of omega. So let's see how much we will get. So what I'll do, this make it 0. 3 divided by 0.31. No, this is 3.8. 3.8 divided by 0.318. This much root over 1.57. Let me check it once again. This is 3.8, correct? 3.8 divided by 0.318. Okay, yeah, root over of this 3.456. so this is our omega value. So here we got the value 3.456, and this much radian per second. So now we got the value of omega, then we can calculate the speed. So speed omega equal to, we know that 2 pi n by 60. So now I can write n equal to omega how much? 3.456 into 60 divided by 2 into pi. So let's solve it immediately. Here multiply 60 and divided by 2, again divided by pi. So 33.010. I hope I have done correct. Anyway, so 33 we can write here, 33 RPM. So here we got the value of 33 RPM. The same thing we need to do for the delivery strokes. Okay, then which specific speed, which speed is less, or which is the less speed will get, that is a maximum speed of the, like what is the in between the suction and delivery pipe, which n is less, that need to be considered for the maximum speed of the single acting reciprocating pump to avoid the separation. So this is the first. Similar way I'll do for the delivery strokes. Okay, the second condition, that is our delivery stroke. So same formula we can write here, only slight changes will be there. Slight changes will be there in this. In I can say like both will be similar way. Like here HATM only plus HD. Here it was minus. Here it is plus. Remaining all will be same. This is H separation, and this is LD. Now on behalf of LS, you need to write LD. LD by G into A by here AD. On behalf of AS, AD into omega square R. Similar way again we need to write all these values of here. See, this is 10.3. HD is given how much? 13. So this is 13 minus H separation how much? H separation is 3. And this is in this side LD. LD is given how much? This is a little bit lengthy, 20. This is 9.81. And A is here 0.1 square divided by AD. AD is how much? Diameter. What is the diameter is given? 0.03. So here we need to divide 0.03 square. Multiply. Again omega is unknown and R equal to 0.1. I hope correct. Yeah. So these are the values are given for us. Now what we need to do, again same procedure, just we need to follow. Let's see. In this left hand side what we'll get? 23.3 minus 3 is 20.3. It is very easy to find out 20.3. And other side if you see, so anyway we'll calculate with the help of this calculator. Let's see how much we'll get here. So 20 divided by 9.81. Okay, 20 divided by 9.1 into 0.1 to 0. Okay, no, minus. Again I've done mistake. 20 divided by 9.81 into this is 0.1 into 0.1 to 0.1. Even a whole cube also you can do. Anyway, divided by this is 0.03. Again 0.03. So 2.26 we got here. 2.265 omega square. So I can write here 2.265 omega square. So similarly I can write here omega square equal to 20.3 divided by 2.265. And similarly here again you can write the same statement, omega equal to, this is root over of 20.3 divided by 265. Okay, now what we'll do, just we'll find out the value of omega here. So again we need to take this help, like 20.3 divided by 2.265 suppose, and root over of this 2.9937. So you can write 2.994. So now we got the value omega equal to 2.994. Okay, so this is the value. So this is the value of what? Omega. So this much radian per second. Now what is our intention? We need to find out the n value. So n equal to, let me write directly here 60 into omega. So 60 to omega in the sense 2.994 and divided by 2 into pi. 2 into pi. So which value we got here? Already there, into just multiply into 60 and divided by 2 divided by pi, 28.58. So here we got the value n equal to 28.58 rpm. Okay, so this is our value, second rpm. So first rpm which one? 33 rpm we got. Now which is the minimum of the two pumps? Minimum of the two in a single pump, two speeds are there. This is for suction stroke speed, this is for delivery stroke speed. So which value is the minimum of these two different speeds? Okay, that is the maximum speed of the pump need to be considered. Without separation we need to consider. So your maximum speed, now you can write final answer, maximum speed without separation, maximum speed without separation equal to 28.58 rpm. This is our answer. So I hope you understand the answer. This is the formula we need to remember for the suction stroke. This is the formula we need to remember for the delivery strokes. If you are not able to remember, then again we need to go back to the diagrams. Then we need to identify from there that condition we need to remember. Anyway, so this is the method how to solve the problem. I hope you understand. Still, if you are having any doubt and query regarding this, you can give a comment on the comment box.